video will be the rest of your Chapter 5 corrections. I decided to put it in one video instead of all those shorter videos. If I could get my smart notebook to open. Okay, so I left off with, I finished number 11, so we are going to start with number 12. Find the average value of x, 3 to the x squared, over the interval from 1 to 4. So to do that, you would want to do 1 over b minus a, so that's 1 over 4 minus 1, integral from 1 to 4 of x3 to the x squared dx. U will equal x squared, du equals 2x dx, so we divide by the half. Okay, so now we substitute. So 1/3 times 1/2, the integral from 1 to 4 of 3 to the u du. My formula for a to the u is a to the u divided by the natural log of a. Our coefficient in this case is 1/6. It's a definite integral from 1 to 4, so we get a crazy large number because we are taking 3 to the 16th over 6 natural log of 3 minus 3 to the 1st over 6 natural log of 3. So it will be 3 to the 15th. So if you actually work that out, this would be the number that you get. So 6,530,468.55. Okay, number 13. Use the trapezoidal rule to estimate the integral from 2 to 5 of 3 over x natural log of x dx using 3 subintervals, and what is the actual area? So if you plug this in your calculator to get the actual area, you get 2.52719. Using the trapezoidal approximation, our graph looks like this. We are going from 2 to 5 with 3 trapezoids. That will look like that. So the area of the 3 trapezoids, 1/2 the height, which is 1 in all of them. 2.164 is the first base, plus 0.91024 is the second base. Of course, I get those values, the bases, from plugging in 2 and then plugging in 3. Then I'll plug in 4 and I'll plug in 5. So this is my f of 2 value, this is my f of 3 value. So my next area is 1/2 the height, which again is 1. My first height, which is what I get when I plug in 3, so 0.91024 plus 0.54101. This is my f of 3 plus f of 4. And then my third trapezoid, 1/2 the height, 0.54101 plus 0.3728, which is f of 5. So we do some number crunching, we add those up, it's 1.53712 plus 0.725625 plus 0.456905 for a grand total of 2.71965. So close to our actual area. The more trapezoids we would do, the closer the approximation would be. Number 14. find g prime of 2 if f of x equals square root of x minus 4 and f of x and g of x are inverse functions. So you could have just found the inverse and worked this one out, or you could have used the formula, which looks like this. So square root of x minus 4 is equal to 2 at x equals 8. So that means f of 8 equals 2 and g of 2 equals 8. So that means I can replace my g of 2 with an 8. So 1 over f prime of 8. My derivative equation is 1 over 2 square root of x minus 4. So I plug 8 into that, and I get a 1/4. 8 minus 4 is 4. Square root of 4 is 2. 2 times 2 is 4, so that is 1/8. So I finish my theorem, and I get 1 over a 4th, so the answer is 4. So g prime of 2 is equal to 4. The 3 multiple choice problems. Number 15. If the integral from 1 to 3 of g of t dt equals 8, what is the integral from 2 to 6 of 1 plus g of t over 2 dt? So this is the integral that we want to work. So I look at that, and I know my u is going to equal t over 2. These are t's as well. So I notice if I take 6 divided by 2, I get 3. And if I take 2 divided by 2, I get 1. So that is going to help us out that u equals t over 2. The derivative of that is a half. So I integrate my problem. I multiply my 2 over. The integral of 1 is t plus the integral of g of u times 2. So this is going to be plus the integral of 2 g of u du. Well, because I divided my t's by 2, this is now a 3, and that is a 1. And the integral from 1 to 3 is 8. So I am going to say the t plus 2 times 8. I need to evaluate my t from 2 to 6, and that'll give me 6 minus 4. I'm sorry, 6 minus 2, which is 4, plus 16, and so my answer is 20. Number 16. The function natural log of x over x is greater than 0, is decreasing on the interval. So I want to take the first derivative, the bottom times derivative of the top, minus the top times derivative of the bottom, over the bottom squared. So if I simplify that, I have 1 minus natural log of x over x squared. I want to know where it's equal to 0. So 1 minus natural log of x is equal to 0 when natural log of x equals 1 or x equals e. We also look at the denominator and see that x would also be 0, but 0 is not in domain. So we're not going to worry about that. I put e on my first derivative number line, and it goes positive, negative. So it is decreasing on the interval from e to infinity. So the answer, correct response was E. And then last but not least, number 17. Is the integral from 1 to e of the natural log of x over x dx, u equals natural log of x, du equals 1 over x dx. So this is the integral of u du, which is u squared over 2 from 1 to e. Substitute your u back in. And natural log of e is 1, so that is 1/2. Plug in 1 and you get 0. So my answer is 1/2, which is C. So the problems that I would like you to do in place of the ones on your test, we won't do any extra multiple choice, but I'd like for you to do for number 12, find the average value. Let's make our function f of x equals 2x times 4 to the x power on the integral from 0 to 1. Number 13, use trapezoid rule to find the area, approximate area of the integral 3 to the x from 1 to 5. Do 4 subintervals and then find the actual area. The last one I want you to do for number 14, if your function is x to the 5th, 127 times x to the 5th plus 2x cubed, and your a value is -11, find the inverse derivative of x at your a value at -11. I actually want you to do one more. Let's add a number 15 in there. If x equals y cubed minus 2y squared plus 2 at the point -4 to 1, I'd like for you to find y prime at that point. Good luck.